Now that you have gone to the site, gathered all the information and photographs, and have transferred the necessary information onto the data collection form, we're going to take that information and now we're going to transfer it into the spreadsheet and generate an energy profile or energy audit. So before you see the form filled out with as much information as possible. There's a couple of things missing. Cost per kilowatt hour is missing. The position of the valves is not there. The type of SPCS that they are looking for is not there. And they did not enter in the measured supply voltage. We do know what the supply voltage was because we took a photograph of the meter when we were doing it. So let's begin to fill in the site data now. So here's our blank form. This is on the actual spreadsheet itself, and it's called the SPCS data collection form. So let's start at the top and begin to enter data. So we have the school name. We have a pool circulation pump. This facility is open all year. So it has a 1/1 opening date and a 12/31 closing date. Facility was built, I believe, in 2008. And this is an indoor installation. We saw that in our photographs taken previously. The hours of operation, we are closed on Sunday, so we're going to enter in basically the same exact time. So I'm going to enter in 8 a.m. and I'm going to copy that to the cell right below it. Same opening and closing time yields 0 hours. I'm going to put in Monday. They are open at 6 a.m. and they close at 5 p.m. So we're going to change 8 to a 6. Paste this again. And then we're going to change this to read 5 p.m. Once those are in there, we can copy those two cells and then we can paste them into Monday through Friday. And then on Saturday, we can copy those two, paste them in, and then change it to 8 a.m. for the opening day, opening time. And this one closes at noon or 12 p.m. Since we didn't have a cost per kilowatt hour, we're going to use 13 cents. It's sort of a standard middle of the road. We're going to leave this area untouched right now because the valves are probably closed, but we don't know exactly how far. So we have a PACO pump, and it's a 29-5015. Because we know because of the motor frame size and the photographs we took that it is a horizontal split case, and that has a designation from PACO of KP. The serial number taken straight from the nameplate. We'll enter that here. We kind of keep a track of that because if we ever need to go back to the manufacturer for parts, pieces, or to verify something, they almost always require a serial number. The size on a 5015 is 5 by 6 by 15. From the nameplate, we have 1,000 gallons per minute and 68 feet of head. The impeller diameter from the nameplate is 12.9 inches. We'll get the efficiency once we pull up the performance curve and start entering the data from the performance curve. We won't do that quite yet. The motor is a Baldor. It is a EM. This is an older motor, so it isn't Actually, it is a good motor. An EM is an energy efficient model for 111. Nominal efficiency from the nameplate is 93%. The enclosure is TEFC, stands for totally enclosed, fan cooled. Horsepower was 25, 1180 RPM. We measured the site voltage. We're going to drop down to that cell at 472.5. And the spreadsheet in this little green cell will automatically give you what the SPCS mains voltage wants to be. In this case, it's going to be a 460 volt system. So we look at the nameplate and we know that the full load amps at the site voltage of 460 is 31. And this unit had a 324T frame. The nameplate voltage was 230, 460 volt. And we're going to go over to the pictures we took of the gauges. The flow meter was 714 gallons per minute. Filter influent was 24 psi. Effluent was 14 psi. And our return pipe size was 8-inch. It's going to now use 8-inch pipe and the flow rate, and it's going to calculate the velocity for us. So this little divide by 0 will disappear and immediately change into 6.4. That's a good velocity for pipe. 10 foot per second is considered the maximum allowable by code. Anything less than that, between 6 and 7, is ideal. It's going to be a very quiet system at that. Backwash differential is between 12 and 15 psi. Since they didn't give us that info, we'll use 12. This pool has a 6-hour turnover rate. And when we enter the pool volume here, it will tell us what our flow rate for a 6-hour turn should be. And the volume we had at 337,000 gallons, and 936 gallons per minute would be the required turnover rate. Since we did not get any of this information, we know that this is an existing system and we're going to be retrofitting, so the odds are pretty good that we'll be using the EF system, which is an EcoFlex. There is nothing special about it, so nothing gets entered there. Then over here, we just change that lowercase o to a lowercase x. We have a photo of the pump, and we have a photo of the motor. It's going to be integrated with an existing controller. There were 4 filter tanks. It was a Bex SIS controller. It was an Echo 3 filter system. And it was a Model 7 Bex's controller. There was no filter control because the Bex's controls that, so it'll be N/A. Okay. Looks like we've got it all filled in now except for the design efficiency, which we will get off of the pump performance curve. Next video, we'll pick that up.